Guys, how's it going? Let me go back here. Let's see. Oh, how do I go back? There we go. Okay, awesome. So we're going to call a little bit of an audible here. It's going to go a little bit differently than planned, but that's all right. We're all flexible, right, as scientists and engineers, right? So I'm Daniel Whitenack. Whoa. I work at a company called Pachyderm. It's a startup. It's built around an open source framework, which I'll talk about here shortly. But today I'm going to be talking about putting the science back in data science. And really what I mean by that is the fact that one of the main tenets of science is like reproducibility, right? And if you worked in science or you worked in academia, we kind of know that that's not always the case, even in science or academia. But basically today I'm going to talk about why reproducibility is really important in data science specifically, and what are some ways that we can enable reproducibility in our workflows, and also some best practices around collaboration. So none of us works on necessarily by ourselves. Most of us don't. We work on a team, okay? And regardless of what you hear in Twitter or on blogs or whatever, there's no such thing as a data science unicorn. There just isn't. So we work on teams. We all have kind of different sets of knowledge, and we need to work together to solve complex problems. And if I develop solutions and I can't hand those solutions off to my teammates and have them reproduce the analysis that I did, then there's no chance for us to have like this productive teamwork, and there's no chance for them to critique what I've done, and there's no chance for them to be able to incrementally improve on what I've done. Secondly, as a data scientist, I don't know about you guys, but I'm pretty forgetful. I like forget what I did yesterday, and so even just for myself to remember what I did and help myself improve my process, I need to be able to have some way to like accurately reproduce what I was doing. Finally, the last reason is that you might not actually have a choice anymore for very much longer. So some of you guys might be aware that there's a lot of regulations being passed around like algorithmic decision making, particularly in the EU. So you might have heard of like the GDPR. And basically what this is saying is that in many cases, users have a right to an explanation for any algorithmic decisions that are made with their data, which in this room should terrify all of us. Because we're producing a lot of things now, some models with 60 million parameters that I don't know how to explain to myself. So I mean, this thought of like being able to reproduce what you've done and understand the behavior that happened at some point in history becomes very important. So if we lose slides, then I'm just gonna like keep going. So pay attention. All right. So then, yeah. So in many cases, you might not have a choice of whether you want to care about reproducibility or not. Okay. All right, so this is like why we should care about reproducibility. And we're back. The next reason, okay, or the next thing is, let's talk a little bit about how we can achieve reproducibility. What are some best practices around our workflows that would allow us to kind of make our workflows a little bit more reproducible in general, okay? So the first thing that I want to propose to you guys is that we should, it's kind of a little bit counterintuitive for like scientists and engineers who like we're all kind of naturally curious, right? And we like really cool solutions. But I'm going to propose to you guys that we should actually strive for and celebrate simple solutions to problems. So like elegant, simple solutions to problems should really be what we're searching for. So if you're on my data science team, and we encounter a problem and we could solve that problem perfectly well and give the insight that we need to give by calculating a maximum value, and you bring me like a convolutional neural net that you worked 2 months on, then I'm not going to be the most happy guy in that code review. So like simple solutions are just by their nature more reproducible, and you're going to have less headaches as you as you implement them, as you move them to production, your teammates are going to be able to understand them a lot easier. And so this is really what we should strive after. So we'll take a little bit of a survey. So how many of you, or how many lines of code do you think you could write before you introduce a bug? What do you think? You got 2 lines? Anybody else? What do you think? Like, what on average, what do you think people, how many lines of code do they write? 30? 10? Yeah, so you guys are kind of around the right range. So it turns out it's about like, 20 lines of code before you introduce a bug. So just by like adding more code, by adding like more complication into your solution, you're making your problem less predictable. You're potentially introducing more and more bugs. Okay, and this is actually like a real problem. Like, we talked a lot about like reproducibility and why we care about it. But I mean, let's take it a step further. Like, we're producing applications for users, and we intend them to make decisions based on our applications, right? Based on our predictions. If our application doesn't behave like in a reproducible manner, and it produces some weird behavior, and what's even worse, if we're not able to understand why it's producing weird behavior, guess what? Like, those people are never going to trust your predictions again. So like, even if you fix the model, if you fix it, from my experience, the end users that I interact with, they will never ever trust your solution again, even when you fix it. So like, this is a real problem, and it gets to like the real practicalities of, okay, cool. Is there a trick to this, or no? Okay. All right. So we're talking about keeping your solution simple. The next thing that like I want to propose to you guys is that reproducibility should be a precursor to putting anything into production. Okay, so when you're moving your application off of your laptop into some sort of data pipeline, into some sort of production environment, similar to like there's best practices around software engineering that you need unit tests, you need code reviews, your code needs to be versioned. We as data scientists should really be forcing this idea of reproducibility. And some of you might kind of come back to me on that and say, oh, well, Daniel, like, you don't understand. Like, my model is non-deterministic, and it's not going to, produce the same number every time. So I totally get that, but I disagree with your conclusion. So I come from physics originally, and I did like quantum mechanics stuff. So the electron, if you measure an electron, it's going to be over here sometimes and over here sometimes. It's going to depend on the certain case, and you might not always get the same answer, but you have a very, very strict theory around it, right? So before you put something into production, even if there's some amount of randomness to it, you should understand the range of values that you expect, the variance of those values. You should know what the expected behavior is of what you're deploying. Okay, seem reasonable? Yeah, okay, some nods, I guess. All right, so the last thing that I want to propose as kind of a best practice around this is that we should and we really need to be versioning our data. Okay, so like I mentioned, software engineering has been kind of developing best practices for a long time, and now if you go into like a software engineering team and you're not versioning your code, right, then you're going to like get kicked off of the team eventually, right? So, is it just going to sleep? Oh, there you go. Awesome. Okay. But the problem with data science stuff is that even if you're versioning your application, if you're versioning your code, right? By the fact that like we have these machine learning workflows, we have other like statistical analyses, these things are going to produce wildly different results depending on what training set we put into our model training, depending on how our data changes. So like if I give you just my code, you have no chance of reproducing like my exact workflow without my data. Okay? And similar, like when we put things into production, if we're not tracking, like if we're pulling data from a users table, and then we do that every 5 minutes and produce a result, and then like 2 days ago we realized that we produced this weird behavior that we want to investigate, well, guess what? Like your users table is in a different state now, and you don't have the exact data that was exposed to your model at that time. So you have a very hard time, you know, figuring out why your stuff is behaving differently. Okay? So there's a variety of ways to version your data in terms of your workflow. There's various projects out there. There's various like solutions being proposed. I'm going to talk about one of them today. It's by no means the only one, but it's the one I'm most familiar with because I work on it. So let's talk a little bit. All right, perfect. So we're going to kind of quasi go through this demo. And the purpose of this demo is not really to like show you any like cool new machine learning technique. The purpose of this is to really show you a very simple machine learning technique and show you that the workflow surrounding it already introduces some issues and challenges around reproducibility and your workflow. So the scenario is we're all at like this really innovative gardening company, right? And we know that our users, like all good gardeners, really like to take measurements of their flowers, right? And in particular, like we're a very niche market. It turns out like our gardeners only take measurements of iris flowers, okay? So what we want to do is we want to help our users out, and we want to take in these iris flower measurements and then classify the species of these flowers. Okay, so I'm being a little bit ridiculous. Like probably everyone in this room has solved this problem, but I want to demonstrate kind of how this problem in a you know, quote unquote real world workflow already introduces some issues and challenges around reproducibility and collaboration. So we're working on a team, right? And we're trying to solve this problem. And so I take my first stab at it, right? And I say, okay, I'm going to write this R script. It's going to take in this CSV of my training data. And then I'm going to train some model. And I'm going to persist that out as RDA file and maybe some metadata with it, okay? And I'm doing this because I don't want to retrain my model every time. I want to persist it and then use it to make predictions or inferences, okay? And then I say, okay, I'm going to have another R script, and that one is going to take in this model, and then it's also going to be able to take in like new sets of attributes and produce the corresponding species for those attributes, okay? So to make those inferences. So does this seem reasonable to everyone? Does it seem okay? All right. So like I developed this on my own, right? And then it seems reasonable to me, it seems reasonable to you, but then this isn't really like what my team sees, right? And it's not really what I see once I forget about how I set up my workflow. Really what you see is more something like this, right? You see some R scripts and there's some pieces of data around, and maybe you guys have got into this scenario on one of your team. You start like seeing like this sort of jumble, and then you start trying to name things so they make sense. So you get like my good plots underscore with configuration 2 on Tuesday of, you know, that one good week dot py, right? And so like you start getting into this scenario where increasingly it's hard to like understand how all these things fit together. And now even more, if we're now thinking about, okay, we have a good workflow and we want to put it into production, now we have to think about like scaling concerns. We have to think about like, maybe I want to run this in parallel or over many workers, and that's going to introduce more complication, and I'm probably going to have to change my code or hand it off to like some Java guy, and he's going to implement it, and then he's not going to understand the model, and then I'm not going to understand the implementation. And so like, there's just a lot of complications, not only with this, but then thinking about productionizing this, right? So what I'm going to propose to you is that how I like to think about this is I like to think, wouldn't it be cool if we could take this same workflow and more strictly define our workflow so that it's reproducible, but also do it in a way to where we don't have to complicate our code and we can make it scalable and run it on a production cluster. So this is where this open source project that I work on, Pachyderm, comes in. So Pachyderm is an open source project. It's completely open. You guys can try it out today on your laptops if you want. But it does two things. It does data pipelining and data versioning. Okay, so the same workflow in Pachyderm, the way we would think about it is this way. So this is like the same flow that we had before. But what we're going to do is kind of follow some of the best practices that I proposed before. Okay? We're going to keep our code simple. So in each of these pipeline stages, that's the same exact code. Again, like I can show you the demo later, it's the same code. It just is those R scripts that take in files and write out files. And then also we're going to version our data. So each of these like cylinders here that I've represented in Pachyderm, in a Pachyderm pipeline, is a versioned set of data. Okay? So all of the input and output of each stage of the pipeline is completely versioned. And that flows in between the connectors or these pipeline stages, and you can run anything in here because this is all built on software containers. So if you're not familiar with software containers, you should look them up, look up Docker containers, but basically I'm just throwing this script into a Docker container. I could just as well throw Python in there or TensorFlow, I could run a bash script, whatever it is. So now there's actually some interesting properties that come out of combining this data versioning with data pipelining. First of all, because each one of these inputs and outputs is versioned, I can do things like say, this exact inference that I made last Tuesday, right, came from this exact version of my model, which was trained on this exact data set, right? And then over time, as I change my data set, as I change my model, that complete history is tracked, okay? So I can always go back and for one, exactly reproduce anything that I produced before, because guess what? I have the containers and I have the exact state of the data at that time. But I also can do things like say, very quickly, like what is the whole string of things that contributed to this particular inference. And I can know like all of the tracking of what stages and what data came in and what changed that produced that result. You can also do kind of, this is less related to reproducibility, but in terms of processing, since now we're aware of what data is changing, like if I have already processed like 1 million of these attribute files and I add one more, I know which one is new, right? I don't have to reprocess all of them. My pipeline just updates for the single new one. So this is nice. This kind of like fits together the different like reproducibility and now this kind of provenance idea. And I'm able to deploy the same thing I was running on my laptop into this pipeline without adding complication. But now let's think about like the scalability thing. I mean, this is still like single-threaded R script running. It takes in a file and it outputs a file. But since Docker containers, if you're familiar with them, they're really lightweight and they're easy to push across the cluster. So what we can do if we want to, for instance, now we have a bunch of gardening users, right? And they're putting a bunch of files in. We can just spin up, 100 of these workers, right? All of them running my same exact simple R script, but they're going to process all of those attributes in parallel, and Pachyderm will take care of spreading those across the workers. So hopefully this gives you a little idea. Again, like come up to me later if you want to see the demo. I've got it running, so like we can do that during lunch or whatever. But I just want to emphasize at the end, like this is kind of like a toy model that I've shown you, but it gets really powerful when you start saying like, I have this workflow and then I want to add something else in Python to produce some plots, right? And then I want to do some pre-processing with Julia to produce my training set. And then for some reason I want to run a bash command on some raw attributes to change the format or something like that. So now you're creating these very complicated multi-stage workflows, which is a part of what we do as data scientists. But you have complete version control over the entire analysis pipeline and scalability of each one of these stages independently in whatever way that they need to be scaled. Okay, so like I say, come up to me afterwards. Try to grab me earlier in the day because I was on a plane like all night last night, so my cognitive ability will be going down rapidly. But feel free to follow up. So I'm going to post these slides, all of the code for running like what I just showed you on a production cluster, which you can run in a VM on your local machine. That's online. The link will be there. We have a public Slack channel if you just want to ask questions and talk to other Pachyderm users, open source users. Of course, there's the docs. You can find me on Slack and on Twitter there. And then there's a related article as well on O'Reilly about this, about reproducibility in data science. So thanks for bearing with me through the difficulties.